term counterpoising ground is not a commonly recognized term in standard electrical engineering practices or within widely used resources like the National Electrical Code. When encountering unfamiliar terminology within a specification, especially related to critical aspects like grounding, the most prudent approach involves direct communication with the originator of the specification. In this instance, that would be the electrical contractor who provided the document. Requesting clarification serves several important purposes. Firstly, it ensures a shared understanding of the intended meaning and technical requirements. Secondly, it allows the contractor to elaborate on the specific context in which they are using the term. Thirdly, it provides an opportunity to identify any potential local practices, project-specific deviations from standard norms, or specialized interpretations of existing codes. Grounding systems are a fundamental element of electrical safety and performance. A ground ring encircling a building, as mentioned in the specification, is a common technique to establish a low-impedance ground reference. Typically, a ground ring consists of a bit copper conductor, often 4/0 American wire gauge or larger, buried in the earth around the perimeter of the structure. This ring is then connected to the building's grounding electrode system, which may include ground rods, metallic water pipes, or concrete encased electrodes. The purpose of the ground ring is to provide a path for fault current to flow back to the source, facilitating the operation of overcurrent protective devices like circuit breakers and fuses. In addition, it helps to equalize potential differences within the building and minimize the risk of electric shock. The term counterpoising, in general engineering contexts, often refers to a balancing or neutralizing force. Therefore, it's possible that the contractor is using counterpoising ground to describe a specific technique for balancing ground currents, mitigating electromagnetic interference, or achieving a particularly low ground impedance. Without further clarification, it's difficult to determine the exact meaning. It is also possible that the term is simply a misnomer or a non-standard way of referring to a common grounding practice. Here are some potential interpretations of what counterpoising ground might refer to, although these are purely speculative without additional information. Firstly, a technique to balance ground currents. This could involve strategically placing grounding electrodes or conductors to distribute fault current evenly and minimize voltage gradients. Secondly, mitigation of electromagnetic interference. In sensitive electronic environments, a counterpoising ground might refer to a grounding system designed to reduce noise and interference by providing a low impedance path for straight currents. Thirdly, a specialized ground ring configuration. The contractor might be using the term to describe a ground ring with specific characteristics, such as a particular depth, conductor size, or connection method. Fourthly, connection to other grounding systems. Perhaps it describes the interconnection of a ground ring to other grounding systems such as those for separately derived systems or other building structures. Fifthly, a local or regional term. It's possible that counterpoising ground is a term used only within a specific geographic area or by a particular group of electricians. When seeking clarification from the contractor, ask specific questions about the intended function of the counterpoising ground. For example, you could ask, what is the purpose of the counterpoising ground in this application, or how does the counterpoising ground differ from a standard ground ring installation? Also, ask for any relevant documentation or references that support the use of the term. Request a detailed explanation of the installation procedure for the counterpoising ground, including the materials, dimensions, and connections involved. This will help you understand the practical implementation of the concept. Furthermore, inquire if there are any specific performance requirements or testing procedures associated with the counterpoising ground. This will help you determine if the installation is meeting the intended design criteria. Remember that grounding systems must comply with the National Electrical Code and other applicable standards. Ensure that the contractor's explanation of the counterpoising ground aligns with these requirements. If you have any doubts or concerns, consult with a qualified electrical engineer or inspector. The NEC provides comprehensive guidelines for grounding and bonding electrical systems to ensure safety and proper operation. Some relevant sections of the NEC include Article 250, which covers grounding and bonding in detail, Section 250.52, which addresses grounding electrodes, Section 250.66, which covers size and grounding electrode conductors, and Section 250.166, which covers size and grounding conductors for alternating current systems. In addition to the NEC, other industry standards, such as those published by the Institute of Electrical and Electronics Engineers, offer guidance on grounding and bonding practices, particularly for specialized applications. Understanding the purpose and implementation of grounding systems is crucial for electrical engineers and contractors to ensure the safety and reliability of electrical installations. Therefore, when faced with unfamiliar terminology like counterpoising ground, it's essential to seek clarification and ensure that the installation complies with applicable codes and standards. Grounding is not simply a matter of connecting to the earth. It is a carefully engineered system designed to protect people and equipment from electrical hazards. Effective grounding provides a low impedance path for fault currents, allowing overcurrent protective devices to quickly interrupt the circuit and prevent dangerous voltages from appearing on conductive surfaces. It also helps to minimize electrical noise and interference, ensuring the proper operation of sensitive electronic equipment. A well-designed grounding system considers factors such as soil resistivity, fault current levels, and the presence of sensitive electronic equipment. It uses appropriate grounding electrodes, conductors, and bonding techniques to achieve the desired performance. Regular inspection and testing of grounding systems are essential to ensure their continued effectiveness. Over time, corrosion, loose connections, or other factors can degrade the performance of the grounding system, potentially compromising safety and equipment protection. Therefore, it's important to establish a maintenance program that includes periodic visual inspections, resistance measurements, and other tests to identify and correct any deficiencies. The NEC requires that grounding systems be tested and inspected regularly, and it provides specific guidelines for these procedures. By following these guidelines and implementing a comprehensive grounding program, electrical engineers and contractors can help to ensure the safety and reliability of electrical installations. In conclusion, while the term counterpoising ground may not be widely recognized, the principles of grounding remain fundamental to electrical safety and performance. By seeking clarification from the contractor, consulting relevant codes and standards, and implementing a comprehensive grounding program, you can ensure that the electrical installation is safe, reliable, and compliant with all applicable requirements.